Have you ever wondered how experts actually read a megacity's green spaces? Well, welcome to this explainer. Today, we're diving into a fascinating geographical detective story. We'll be exploring a study from applied ecology and environmental research that reveals exactly how scientists quantify the shape, size, and fragmentation of nature when it's hidden right in the middle of a massive concrete jungle.
Okay, let's start with a truly staggering number, 24.15 million. That is the population of the Shanghai metropolitan region alone. I mean, just wrap your head around that scale. With experts predicting that 60% of the entire world's population will live in cities by 2025, megacities are facing an immense, frankly unprecedented challenge. How do you maintain a city's green lungs while simultaneously balancing explosive economic growth and massive high-density investment?
Okay, let's dive into this and lay out our roadmap. First step, the urbanization challenge. Second, 6 shades of green. Third, the moving window method. Fourth, finding the perfect scale. And finally, we'll wrap up with a concentric circle reveal.
Step 1, the urbanization challenge. So here is the core mystery. How on earth do you measure something as massive, dynamic, and, let's face it, chaotic as a megacity's greenery? As these concrete jungles keep expanding and eating into suburban agricultural lands, researchers urgently need tools to quantify and optimize green networks. You can't just plant trees at random and hope for the best. You really need a system, a strategic green network of rings, wedges, and corridors to mitigate urban heat, cut down pollution, and actually support local biodiversity. But obviously, before you can build that network, you have to precisely measure what's already there. You need to know the degree of fragmentation, the exact patch sizes, and the spatial distribution of literally every park and grassy verge in the city.
Moving on to part 2, 6 shades of green.
To solve this landscape mystery, we first need to identify our suspects. So researchers standardized Shanghai's greenery into 6 distinct categories based on China's national standards. First, you have public parks, which include the big stuff like zoos and historic gardens. Then, residential green spaces, which you'd find integrated into housing communities. Next are attached green spaces. These are usually linked to industrial or municipal facilities. We also have roadside green spaces running right along the streets. Then there's production and protective green spaces like plant nurseries and windbreaks, and finally, agricultural land, covering all the cultivated fields and forests out on the city outskirts.
Now, what's really interesting about this breakdown is what happens when researchers calculated the percentage of landscape, or plant. A stark dominance emerged right away. Public parks captured over 30% of the sampled green area, while attached green spaces made up roughly 26.5%. Together, those two totally dominate the city's green footprint. However, the data also showed something else. Residential spaces had the absolute highest patch density. In plain English, it means they were highly fragmented into lots of tiny, scattered little pieces spread all across the city.
All right, part 3, the moving window method.
Now we get to the methodology. Think of the moving window method like a giant digital magnifying glass that's systematically scanning across a massive map. Instead of just mushing the green density of the entire city into one big, messy average number, researchers slide a specifically sized window along a straight line. As it moves, it calculates the exact metrics of the greenery inside that window, step by step, kilometer by kilometer. When you map this technique onto Shanghai, you can see 160 of these belt transects running west to east and south to north. By setting the famous Lujiazui central green space as kilometer 0, researchers slid their analytical window outward in 1 kilometer steps. At every single stop, they calculated things like patch size and landscape shape. It's an incredibly precise way to track changes. Which brings us to part 4, finding the perfect scale. So, a magnifying glass is only useful if it's actually in focus, right? The researchers had to figure out exactly how big their moving windows should be. They tested windows of 3, 4, 5, 6, and 7 kilometers. And this brilliantly illustrates a very specific statistical problem. When you look at the 3 and 4 kilometer data, you get these sharp, erratic zigzag lines. That shows how small windows fluctuate wildly, creating tons of statistical noise just from local, street-level variations. But on the flip side, when the window was too large, the distinct changes in the urban landscape got totally smoothed over and completely lost. The big reveal here? 5 kilometers. The researchers discovered that 5 kilometers was the exact spatial sweet spot, basically the Goldilocks zone. It wasn't too noisy, and it wasn't too vague. It yielded perfectly reliable metrics that urban planners can actually use today to accurately map changes from the dense downtown core all the way out to the rural suburbs.
And that leads us perfectly into part 5, the concentric circle reveal. As that 5-kilometer window moved from the center of the city outward, a fascinating, stark pattern emerged. Right in the inner city, the old city core, patch density was incredibly high. The greenery there was dense, but highly fragmented, meaning it was made up of lots of scattered small parks and detached green spaces. But as the window moved outward into the suburbs, the metrics completely flipped. The mean patch size increased exponentially. Out there, the landscape is dominated by huge, continuous, and highly concentrated agricultural tracts with very, very low fragmentation. And this transition wasn't random at all. It happened in very distinct rings.
So the crucial point is this. Shanghai's greenery radiates outward in organized rings, which perfectly mirrors the classic concentric circle urban evolution theory. Now, what's really incredible about this finding is that this theory was originally developed to describe old, well-established Western cities, places like Chicago. Yet here it is, perfectly describing the spatial layout of a hyper-modern, rapidly expanding Chinese megacity in the 21st century. Pretty wild, right? Which leaves us with a pretty big question. Right now, Shanghai fits the classic mold. But as it continues its unprecedented growth, prioritizing these massive new greening networks to become a true city in a forest, will it eventually outgrow these old models? I mean, as these coastal megacities evolve at speeds we've literally never seen before, they might just require a brand new theory of urban development, one that we're only going to discover by continuing to push the boundaries of spatial analysis. Thanks for joining me for this explainer, and remember to keep questioning the hidden structures of the cities around you.